Product development framework is an innovative way of creating a new product in ESDM industry. The detailed step-by-step approach in any hardware design engineering will reduce or mitigate the risk of failure in the product. As we are heading towards the end of this course, it is essential for us to know the detailed approach for designing a new product in PCB industry or ESDM industry as a whole. In this video, I'm going to discuss you the 9 important steps involved in new product development as we discussed in previous video, and in this particular video I'm going to talk about the dual voltage power supply as an example to demonstrate the 9 steps involved in new product development activity. Hello everyone, I'm Vaibhav Sugandhi, passionate PCB designer and technology startup founder. Welcome back to our course on PCB designing for absolute beginners 2022. I believe you have watched our previous video. If not, click on the I button here and do watch that video before watching this one. If you like our educational content, then consider subscribing to our channel and sharing this content with your friends and colleagues. Alright, I believe that you are able to see our screen right now. So here I have a product development framework with the example of dual voltage power supply. Now let us talk about the steps involved in this particular activity. Of course, in previous video I have discussed about the product development cycle where I have covered 9 important steps to be covered in new product development activity. But this one is totally related to hardware design. There is no firmware or there is no software design in this particular product because we are taking it as a simple one so that as a beginner you can understand this one. However, we are going to jump into the 9 important steps in this new product activity, wherein the first step is all about product ideation and application analysis. In this particular activity, we are going to discuss about why we need this particular product and what is the idea behind developing this new product. And the next part is all about black box analysis, and the next is white box analysis. Then we are going to head towards the datasheet analysis. Thereafter, we have a circuit diagram from the typical application section from the datasheet analysis. These are the 5 theoretical activity which you have to do before jumping into a development activity. However, the next 4 step, which is all about schematic design, footprint verification and validation, and also PCB layout activity and manufacturing files. All these things are little practical with the software which is EDA tool, and in our case it is Easy EDA, and we are going to do practically how that product need to be designed. However, in this particular tutorial or in this particular video, I'm not going to cover the 6th to 9th step. In this particular activity, I'm going to cover only from 1st to 5th one. Let us jump into the first important step, that is all about product ideation and application analysis. Make sure that you understand the meaning of ideation and analysis here. You are not going to jump into identifying the circuit for the dual voltage power supply immediately. You are going to understand why exactly this product need to be designed. So first of all, the first question that we are going to ask ourselves is, what is the problem we are solving? Is it dual voltage power supply is a big problem? Do we need to design it, or do we already have any solution in the market? First of all, this is a hypothetical example that I'm taking in this particular tutorial so that you can understand as a beginner. That's why this product is very simple. Dual voltage power supply is very simple. So I don't think so it is a big problem to solve at any cost. But you must understand, you must ask such kind of a questions. This is the example question actually. These are some example questions. You have to ask such detailed questions before jumping into design activity. Now the next question is all about why we need to solve this problem. Of course, if already product is available in the market and it is also cost effective along with the engineering design available in market, why you want to redesign the wheel? That is the question, right? So you must understand why we need to solve that particular problem. Is it necessary to solve the problem, or do we need to change the behavior of the user to use the existing product? or if there is any existing solution, how it is making problem to somebody and how you are going to solve that particular problem. These are the important points you must understand and answer before jumping into the product analysis or product development activity. What are the core applications of this particular ideology? This is another important question. Say for example, if your product requirement is having any microcontroller, why do we need a microcontroller? That is the first question. Can't we do it without using a programming logics? Or can't we do it with any automated circuits that are already available in the market? If it is possible, then why you are spending a lot of time in designing a circuit with a microcontroller and writing a code for that particular microcontroller, which is kind of roller coaster activity in the product development activity. So that's why you must understand why this particular product need to be designed and what are the core applications of this particular ideology. It's not about the hardware, it's not about the technology that you are using, it's about the idea, the problem and the solution that you are developing, whether it is really required and what are the core skills required for this particular product development. Next point is all about what are the core expectations of this particular product. Say for example, if you are designing any product, there must be some core expectation like the bare minimum objectives to be achieved, and there are some special features which might be achievable and may not be based on the situation, based on the available components, based on the requirement, or based on the cost analysis. We are going to decide whether that feature to be included or not. But there are most of the features which are bare minimum, which are essential to define your product. So those kinds of features to be listed out in this particular question. So you must understand what are the expectations of this particular product so that you will understand how to design the product much better way rather than going with a random idea or random objectives. The next important question is whether this product is already available in the market, which is all about DIY or buy kind of a question. Buy in the sense, if it is already available in the market with a cost effective and achievable features that you are expecting, then buying that particular product is the easiest way. Of course, most of the products are not available with the customization that you are expecting. On that time, you need to go with the DIY option, which is all about do it yourself. If you are developing a product, whatever might be the cost, but you are getting the feature that you are expecting. So these are the very fundamental questions you must ask yourself when you are doing the product ideation or the analysis of the product. But again, these are the very example questions. They are not the rock bottom kind of a thing. You can explore hundreds of other questions with respect to your product before jumping into the product development activity. But it is a must and important step before spending any number of hours on designing any schematic or PCB layout and all. But for the practice activity, of course, you can do that, not a problem. For the real-time product, you must exercise this particular activity thoroughly so that you can avoid or you can mitigate the risk of failure in the product activity. Now, next important step is all about black box analysis, which is very fundamental and very essential when it comes to electronic industry. Not only electronic industry, and most of the industries are having these particular analysis as a fundamental. So in this particular example, as we said, it is a dual voltage power supply. We will be having a 230 volt AC as input to the entire system. So that's why 230 volt 50 hertz AC is given as an input, and thereafter we will be having a transformer. Which kind of a transformer, what is the voltage of a transformer, or what is the power rating, all those things are not yet considered at this point of time. There must be a transformer which will transform that 230 volt AC into a lower voltage AC which is suitable for further conversion. So thereafter the transformer, we will be having a rectification circuit which is essential for converting the AC voltage into a pulsating AC, which is essential for you to understand how exactly the AC voltage is being converted into DC voltage. So this rectification circuit will be responsible for converting AC voltage into a pulsating DC voltage. Thereafter, we need a filter circuit which is essential for converting that pulsating DC into a pure form of DC, removing all the AC components in that particular signal. Which kind of a filter we are using, or what kind of a regulator or rectification circuit we are using, we are not yet clear. That's why it is a black box analysis, not a white box analysis. Thereafter, we will be having a regulator circuits which are essential for converting this filtered DC voltage into regulated DC voltage, a constant DC, which is essential for most of the electronic circuit when you are working with electronics. We are having a plus 5 volt 1 ampere output, which is a DC output that we are expecting. Along with that, we are expecting a 12 volt 1 ampere in this entire circuit. As we said, it is a dual voltage power supply. Both voltage should be available at the same time. That is the goal of this entire product. That's the bare minimum requirement or the objective of this entire product. There also we will be having an indicator circuit, which is essential for just to indicate whether these ICs are working fine or not, or the power is coming at the output side or not. Of course, it is optional. Based on your requirement, you can add the indicator circuit or you can remove. In most of the cases, based on the regulator that we are selecting, there is also a feedback circuit which is used for closed loop system. Like if you are having output voltage greater than 5 volt, it will send a feedback signal to the rectifier circuit and it will correct its accuracy and it will make it as a 5 volt back again. So those kind of a feedback circuits are also used in some kind of a regulators. Again, this is a black box analysis, so we don't know which regulator we are using. If we are using a normal regulator without feedback circuit, then this particular block is going to be not used. If we are using any regulator that is having a big feedback circuitry or that demands to have a feedback circuitry, then we are going to add this feedback circuit by default. There are two important points we must understand here. These are the main blocks of dual voltage power supply circuit. They are not mandatory that you need to have these things. You can add any other blocks as per your requirement. But these are the main blocks according to my experience and my knowledge with respect to dual voltage power supply. And feedback circuit is optional with respect to the type of regulator we select. As I already said, the kind of regulator is going to decide whether it is a closed loop circuit or open loop circuit. Now let's jump into the white box analysis. As I said, after doing a black box analysis, we will be doing a little survey in internet to understand what kind of a transformers are available in the market, what kind of a bridge rectifiers or the rectifier circuits are available in the market, and what kind of a capacitor circuit or what kind of a filter circuit need to be used. All those things will be analyzed in the survey activity. Then we will be come up with a one particular part number that we are going to use for this particular design activity. In this white box analysis, we are going to mention what kind of a component we are going to use. In this case, in the transformer case, it is a 12012 transformer. What is the meaning of 12012 transformer? It is a center tapped auto transformer, which is all about having a 3 terminal at the output side, at the secondary side, wherein the center tap or the center terminal is a 0 voltage, the top terminal is a 12 volt AC and the bottom terminal is also 12 volt AC. Why we are selecting a 12 volt transformer or 12012 transformer? So that we can use the two out and extended poles and connect them together to make it as a 24 volt AC. Okay, if we use a 24 volt AC transformer or 24 volt 0,24 volt transformer, it is very costly. So we also need to look into the cost effective solutions, right, and cost effective components. That's why we are using a 12012 and making it as a 24 volt. Thereafter, we will be having a bridge rectifier. There are 3 types of rectifier: half wave rectifier, full wave rectifier and a bridge rectifier. Bridge rectifier is one efficient one and it is having a more effective way of working with respect to the power supply design in general. That's why we are using a bridge rectifier. That too, specifically the part number is 2W10, which is IC of bridge rectifier, which is directly can be used for any product development activity. Other than that, we can also go with the 4 individual diodes, which are 1N4007 or any other part number. But in this case, I'm going with a 2W10 part number as a complete bridge rectifier IC. Then we will be using a capacitive filter circuit, and the specific number or specific value of the capacitor is 1000 microfarad 25 volt at the input circuit. Of course, when we are studying the data sheet of 7805 and 7812, we will get to know the specific capacitor that we need to use at the input side and at the output side, which we are going to accommodate in the schematic design activity. And after the capacitor filter circuit, of course, the regulator which I already spoke, we are using a 7805 and 7812 regulator, which is a simple 3-pin regulator which doesn't need any feedback. That's why we don't have any feedback circuit at this point of time as well. Along with that, we are using a 2 red LEDs or the normal 5mm LEDs for indicating whether the 7805 output is coming or not, or whether the 12 volt output is coming or not. Of course, by using these 2 regulators, we will be getting a 5 volt and 12 volt at the same time. Of course, we need to design a circuit in such a way that both the outputs are present at the same time, because in some circuit or in some application we will be requiring 5 volt and 12 volt at the same time. That's why we are designing a dual voltage power supply, not the switching power supply, which is switchable between two different outputs or configurable between two different outputs. It is a dual voltage power supply. Both voltage should be available at the same time. The part number of each blocks are decided at this point of time, which we are having right now. 12012 transformer, 2W10 is a part number for rectifier, 1000 microfarad and 25 volt is a capacitor that we are using at the input side, and 7805 and 7812 are the two regulators that we are going to use. The datasheet of each components need to be analyzed for the better understanding. At this point of time, as a recording, I cannot go with the data sheet and I cannot explain you the all detailed information with respect to the data sheet. Instead of that, I recommend you to spend a half an hour or 1 hour time to understand the data sheet of each and every component. Just identify the 10 to 15 parameters that we discussed in the previous video. What are the informations with respect to those specific configurations or specific location, so that you can understand how to design a specific schematic for this particular circuitry. Now let us talk about the datasheet analysis. As I already said, I'm not going to explain you the detailed way of datasheet analysis with example and all, but I have few points which need to be monitored when you are studying the datasheet. For example, 7805 and 7812 regulators are having a 1 ampere of maximum current capacity. You must understand this particular information from the datasheet analysis. Why? Because in the requirement they have given already plus 5 volt 1 ampere current rating is required. That means it's a 5 watt power supply. We must design our system to produce 1 ampere at the maximum load capacity when we are producing a 5 volt DC output. Along with that, they are also expecting a 12 volt 1 ampere. That means your both regulators should be capable enough to produce or capable enough to deliver 1 ampere of maximum current at the peak level. So these two components are having a capacity of 1 ampere. In the absolute maximum condition, you can see that it is 1.5 ampere, but in typical circuit or a typical application circuit, you can see that it is a 1 ampere maximum current. We need to use a TO220 package footprint for LM7805 and 7812. TO220 is a package which is dedicated for 7805 and 7812 regulators, which is a part of footprint design activity in the next tutorial. However, you must understand this information at this stage only. Otherwise, if you are using a TO220 package in the footprint design activity or maybe in the PCB layout design activity, but the component that you are going to refer is something else, then you are not able to solder that particular component on your PCB after fabrication. So it is better to have a clarity of the footprint and the shape of the product or shape of the component while doing the datasheet analysis itself, rather than struggling later on after the production. Then we will be having a 1000 microfarad 25 volt electrolytic capacitor, which is having a 3.5 mm pitch, which is again essential part of the footprint design activity in the later tutorial. We must use a 12012 center tapped transformer as a 24 volt source. The reason for this one is you are expecting the system to produce a 12 volt DC output. There are so many losses in between because of the components which we are using, because they are electronic component. To perform their activity, they will consume some power and they dissipate power in the form of heat and all. So if we are giving the input here as a 12 volt only, AC 12 volt, after doing the rectification and the filtering process, you cannot expect the exact 12 volt. And also the regulator will also consume some power or some energy in between, which will dissipate in the form of heat. That's why it is a regulator and it is converting higher voltages into lower voltage. In that case, it will be reduced to 10 volt or less than 10 volt if you are giving a 12 volt here. That's why we must have a greater than 15 volt source at the input, so that you can expect the 12 volt DC at the output of this entire system. To make it very simple, we are going with a 24 volt DC source or 24 volt AC source at the input with the transformer. If you are interested, you can go with a 15015 transformer and you can connect the 15 voltage from one tap and the 0 voltage at the center tap. That is also possible, but in my case, I am going with a 24 volt AC input from directly the transformer 2 poles, direct 2 poles. And we can see that we need to use a 560 ohm resistor and 1 kilo ohm resistor for 5 mm LED indicator. For 5 volt DC power supply that we are designing, we need to go with a 560 ohm resistor, and for 12 volt we need to go with a 1 kilo ohm resistor. Why? Again, I am using Ohm's law, and I am going through the data sheet of 7805 and 7812 and understanding what is their output delivery capacity and all. Based on that, I am going to calculate these two values and then put them into my circuit design activity. So this is all about the datasheet analysis. You must analyze these important points while you are doing the datasheet analysis. Of course, there are more than these points which you have to understand by default in the process of datasheet analysis, which is again essential for schematic design or a typical application circuit activity and all. Now let us talk about the next step, which is all about circuit diagrams. As I already said, the datasheet analysis will give you the typical application circuit by default when you are doing the activity in datasheet process. Now I have one example circuit in front of us, which is a 7805 power supply, which is a single voltage power supply, which we are going to use as a reference, not as a strict rule, because we need a 12 volt DC power supply as well. So our product is a dual voltage power supply, it's not a single voltage power supply, but this is a typical application circuit that we can refer at this point of time. Again, this is available in internet because the product that we are designing is absolutely simple one, absolutely easy one, and easy for the beginners as well. But when you are designing some circuit which are not available in the market, not exactly available in the market and directly available in the internet, then obviously you have to study the data sheet and refer the typical application circuit and create your own circuit by combining them. In this particular case, I have a 7805 circuit here directly available. I need to combine 7812 along with the 7805 so that we can get the both dual voltage in the same system. And also the current rating and the connections are need to be taken care. One more very important thing, the kind of transformer that we are using here, which is going to be a 12012 transformer, should be having a capacity of 2 ampere. It should not be having a 1 ampere. If it is having a 1 ampere, then your 7805 and 7812 both cannot deliver 1 ampere at the same time. You have to divide the current between both of them, which is not possible because the requirement is all about 1 ampere. Individually they should be able to produce 1 ampere or deliver 1 ampere. That's why our transformer should be having at least 2 ampere of current rating. More than 2 ampere is very good, but if it is not possible, then at least 2 ampere is recommended. Keeping these all information in your mind, this is all about your circuit diagram, and this is all about the kind of analysis that we need to do. Thereafter, what is the next step? It is all about going to the EasyEDA tool and creating a circuit, referring the typical application circuit and creating a circuit, and then probably starting with a PCB layout and manufacturing files and all those discussion, which we are going to do those discussion in the next tutorial. But in this tutorial, these are the 5 important steps which you have to cover. I believe you have learned something new in this particular activity. I also believe that you are going to do those 5 important steps involved in new product development activity. If you have any questions, feel free to ask me in the comment section below. For such more informative tutorials, consider subscribing to our channel Linked Frequency. Tune yourself to make a difference.